Hey guys, welcome back. We are on day 3 of finding domain of a function. So when we find domain of a function from an equation, there are two things we're looking for. The first thing is a variable in a denominator, because a denominator cannot equal 0. Then we're looking for a variable under a radical, because what is under a radical cannot be negative. In our first problem, we don't have a variable in the denominator, so I don't have to worry about that first hint. But I do have a variable underneath a radical, so I am concerned with that. What's under there cannot be negative, which means x plus 2 has to be greater than or equal to 0. So x has to be greater than or equal to negative 2. Okay, so in this lesson, I'm going to show you the more formal way of writing the domain. So the domain is the set of all x, and here's how we write that. Set notation, set of all x such that. Okay, so what we have so far is set of all x, and we have such that. The set of all x such that x is greater than or equal to negative 2. In the second problem, we don't have a radical, but we do have a variable in a denominator, and a denominator cannot equal 0. So x minus 3 cannot equal 0, which means x cannot equal 3. So the domain is the set of all x such that x does not equal 3. In our next problem, we have a variable in a denominator again. So that denominator cannot equal 0. So 5x cannot equal 19. So x cannot equal 19 fifths. So the domain is the set of all x such that x does not equal 19 fifths. And again, a denominator with a variable in it, that denominator cannot equal 0. So x squared cannot equal 9. And when we take a square root, remember we've got two solutions. X cannot equal plus or minus 3, because positive 3 squared is 9 and negative 3 squared is 9. So the domain is the set of all x such that x does not equal plus or minus 3. We could also write negative 3 comma positive 3. All right, now on this one, we've got two issues. We've got a denominator we've got a variable in a denominator. We've also got a variable under a radical. So we've got to take care of two things in order to get our domain. First of all, that denominator cannot equal 0. And secondly, what's under that radical has to be greater than or equal to 0 so that it's not a negative number. So 2x cannot equal 16, which means x cannot equal 8. And x has to be greater than or equal to 4. So our domain is a set of all x such that x is greater than or equal to 4, but x does not equal 8. Okay, so what if it turned out that x could not equal negative 8? So we'll just pretend we got x cannot equal negative 8. I wouldn't even have to list it right here, because if x has to be greater than or equal to 4, that already tells me it can't be negative 8. So I wouldn't have had to have written it there. But as it actually is, it's positive, and 8 is greater than 4, so I have to say that it has to be greater than or equal to 4, but not 8. Here I've got a variable in a denominator. A denominator cannot equal 0. Okay, so in this case, I would factor. I'm going to factor out an x out of both terms. X times 3x minus 5 cannot equal 0. So one solution is x cannot be 0. Because if I put in a 0, I'm going to have a 0 out here times whatever's left in here. And that would give me a 0 denominator. The other solution comes from solving this when set equal to 0. 3x minus 5 equals 0. So when I move that 5 over, it becomes positive, and then I'll divide by 3, so I would get x equals 5/3. So I've got two things that x cannot equal. So the domain is a set of all x such that x does not equal 0 or 5/3. Here I've got a variable in a denominator and a variable under a radical. So I've got two things to deal with. The denominator cannot equal 0, and what's under the radical has to be greater than or equal to 0. So x cannot equal 1, and x has to be greater than or equal to -3. So my domain is the set of all x such that x is greater than or equal to -3, and 1 is greater than or equal to -3, so I have to say that x cannot be 1. And last, I've got a denominator with a variable in it and a radical with a variable in it. So I have to say that the whole denominator cannot equal 0, and I have to say that the part that's under the radical has to be greater than or equal to 0. So I'm going to move this negative radical to the other side. 2 cannot equal the square root of x minus 1. And then I'll square both sides. 4 cannot equal x minus 1, and then move that over. X cannot equal 5. And x has to be greater than or equal to 1. So the domain is the set of all x such that x is greater than or equal to 1, and 5 is greater than or equal to 1, so I have to specify that x cannot equal 5.